Good day, Miss Ellis. My name is Aljay Adolphus from the class of Science, and today I'll be demonstrating how to make an indicator using natural materials. And using that same indicator, we'll be testing it on household acids and household alkalis. But before we do that, let's get some basic information across. An acid is a proton donor. A base is a proton acceptor. An alkali is a base which when dissolved in water, it forms hydroxide ions. An indicator is a substance or solution that when placed in an acidic solution, it changes to one color, and when placed in an alkali solution, it changes to another color. The natural indicator that I will be using for this alternative assessment is organic ground turmeric. This can be used as a natural indicator because of its main compound, curcumin. When curcumin reacts with an acid, it keeps its same orange yellow color, but when reacting with a base, it becomes reddish brown. This is because of the hydroxide ions within the base altering the curcumin's chemical structure and giving it a new color. The acid that I will be using for this alternative assessment is almo-batrium acid, which is also known as hydrochloric acid in the lab. Hydrochloric acid is a very strong acid with a very low pH level between 1 and 2. The alkali I will be using for this alternative assessment is chlorix, which is also known by its lab name sodium hypochlorite. It is very alkaline with a very high pH level, usually between 12 and 13. To prepare the indicator, we must mix the ground turmeric powder into the water. Since the natural indicators are now ready, I can now test the first solution, the acidic solution, alma acid, also known as hydrochloric acid. I will be mixing it into the indicator. Since I have already tested the acidic solution, now I can test the alkaline solution, chlorix, also known by its lab name, sodium hypochlorite. I will be mixing it into the indicator. Since the indicator has finished reacting with the two solutions, let's observe the changes that occurred. After the hydrochloric acid within the alma acid reacted with the curcumin in the turmeric indicator, a chemical change occurred, but it wasn't a chemical change that affected the color, so the turmeric indicator stayed orange yellow. This is because the hydrochloric acid lacked hydroxide ions, which is needed for the color change within curcumin. After the sodium hypochlorite within the chlorix reacted with the curcumin in the turmeric indicator, the hydroxide ions from the sodium hypochlorite cause a structural change in the curcumin, which caused a color change. This caused the curcumin to go from orange yellow to reddish brown. Thank you for watching my video presentation, Miss Ellis. I hope you have a wonderful day.